Hello, and welcome back to the Latent Space. I'm Katie Roberts. I'm here all day. And now we have Lars Trieloff. He is a principal scientist, at Adobe,
Yep.
working on cloud-native content and API-first architectures. And you're going to be talking about, this looks exciting, building AI agents in the browser, for the browser, of the browser. This is a hugely exciting talk. So please give it up for Lars.
Thanks, everyone. So every story has to start somewhere, and this story starts with inspiration. And inspiration has to meet you somewhere. And for inexplicable reasons, inspiration hit me. Well, you're going to see where it hit me. It hit me right here in the IKEA restaurant, holding a hot dog and a soft serve ice cream. And I was thinking of lobsters. Open claw in particular. And I've been equally fascinated and scared by this particular species of lobster. One, because it gives, it is the dream of the agent, right? It is an intelligence that is just able to live in the world that matters to you, in this case, your computer, your Mac Mini, and control it. But at the same time, this is also very, very scary, which is why people have been thinking about, okay, how can we constrain this power? How can we put it in a harness? How can we put it in a container? And this was exactly the thought that I had. And I knew of OpenClaw. I knew of NanoClaw, which is putting this idea of a claw inside a little container, almost a Docker container. But then I remembered, number one, I hate Docker and dealing with it, and I don't want this to be installed on my system. One of the reasons is my system is under enterprise management, so IT is going to find out if I'm installing Docker, and they're going to send me an email where I need to justify myself. And as much as I like hot dogs and ice cream, I really hate justifying myself to IT. And the second part of it was that I thought, hey, I've got a container at home. I've got a browser, and the browser is pretty self-contained, right? Couldn't we combine this? So this notion of where is the agent and how is it constrained is a two-sided sword, right? We want the agent to be in a box, but on the other hand, every time we put the agent in a box, it becomes less useful and less powerful. So the interesting thing for me is that the box where most of my work happens to be a web browser, right? I'm working in a big company, so we have literally thousands of SaaS applications, most of which I never have to use, some of which I use regularly and with joy, and some of them I have to use every couple of months, and I despise it. So the other thing is I've noticed that a lot of applications that we are building are essentially putting agents in a little sidebar next to whatever product you're building on, right? And this is essentially the step zero of agent enablement, right? You think of your existing UI and you think, wouldn't that be great if we had a sidebar with an agent sitting right next to it? And I think the canonical implementation of this is Copilot. You have it sitting next to your Word document, and you ask it, can you revise that Word document? And Copilot is saying, I'm sorry, I don't know which Word document you're talking about. Or you have it in Gemini, in Google Docs, and it says, yeah, I know exactly what document you're talking about. I can see it. Sorry, I can't edit it. And then you have tools where you say, yeah, actually, I have some of my information in Slack. I have other information in GitHub. I have other information here and there. And whenever it comes to connecting these, it's not just enough that I want it, and it's not just enough that the agent wants it. It's also that the interconnection needs to be implemented by whoever built the agent harness, and it needs to be enabled by IT. And IT, at least in my case, is very cautious and very slow in approving these things. So we are still waiting to roll out co-work, for instance. So my idea was, what if we have one agent that is sitting in the browser that is able to connect to all of my tools, right? That is just able to talk to all of these through whatever APIs they have. And when you think about this, what are the APIs that web applications have? These APIs are typically things like HTTP, JSON, HTML, a bit of DOM, a bit of here and a bit of there, and we can figure it out. And we also have the problem that if we give access to all of these tools, that the agent doesn't know how to deal with all of them, right? Some of the APIs, the agents are, and the models, I should say, are intimately familiar with, right? You can say, hey, just start remote controlling Slack, and the only thing it asks you, what is your token? On other APIs, it's going to say, hey, I've never heard of this strange thing that you cooked up there. How do I deal with this? And this is where skills come. This is where skills come to play, right? And skills really turn the agent from a theoretically powerful machine into a practically powerful machine. So, how do we get started with this? And the idea that I came up with was an agent that is sitting in the browser. It's actually running in the browser, which means it's not a cloud runtime where the agentic loop runs and you're just displaying it in the browser, but it's actually, the actual agentic loop is in the browser. If you close the browser tab, the agentic loop stops. And at the same time, this agent should be able to control itself, right? It should control the browser that it's running inside. And this is how I come up with this notion of the self-licking ice cream cone. And that's why you find it at sliccy.com, slicky.com. And while building it, there are a bunch of things that I was absolutely sure, well, it's a browser, right? It can display HTML pages, but there are a lot of things that it certainly cannot do, right? It certainly cannot transcode videos. It certainly cannot access my local file system. But I'm fine with these constraints. But in reality, I found during this exploration that there are so many things that my browser can do that I didn't even dare to think about. And that was one of the things that made this exploration extremely fun. And now you're wondering what this slide means. And this slide means that I haven't been showing you a presentation for the past 10 minutes. I've been showing you Slick. I've been showing you the very agent that we are going to talk about. And let's flip the instruction manual around and move it back to the sidebar. So, and one of the big ideas in Slick is this idea of ad hoc generative user interfaces, right? We've been hearing how software is becoming very, very easy to build. And I'm saying, yeah, it's becoming disposable, right? You can build software that is good for just one presentation. And this particular slide here, which is using Three.js and which is using weird animations, is exactly that, right? It's a one-off application, and how many are we? And I just hope that that Slick is not going to judge me for my terrible typing.
Hello to all 80 of you in the latent space. It's a pleasure to finally meet the humans I've only heard about through Lars. Thanks for coming.
Okay. Well, it took say very literally, and if you know that say is actually a command on macOS that I thought was fun, so I had it ported over. And with this, we can continue and go into the first concept, and these are sprinkles. Yeah. And sprinkles are essentially HTML files running in an iframe that are being loaded in the sidebar. So I'm flipping around this concept of, oh yeah, the agent is on the sidebar. No, the app's on the sidebar. The agent is the main thing. And it has the ability to self-inspect what sprinkles are there, open sprinkles, and so on. And one of the most interesting things is that there's interactivity or interaction between the sprinkles and the agent itself. So whenever I advance a slide, I said, send an event over to the agent. This event is called lick, because we're talking about ice cream here. And this is how you see the agent commenting on every single slide I've been showing. I've had applications where I said, yeah, you know what, we are just going to have a button, and when you click the button, you just tell the agent that the button has been clicked, and the agent is going to find out what to do next, right? So, and wait, I think we have a. So here we have an example of this, which is I can click a button here. This is sending an event to Slick, and Slick is then saying, yeah, what is the cone in the Slick architecture? Well, the cone, that's the piece of the ice cream that is the user interface that you're interacting with, and it can either change the UI on the fly or just respond in the chat. So, here we go. Here's my. Let's bring this back to full screen. So, and to make this fun, one of the additional things that we have in Slick, not so fast. One of the additional things that we have in Slick is that licks cannot just be fired from inside a sprinkle, but you can also have a cron job as a lick, right? If in case you want to have repeated jobs, you can have. You can also register a webhook, which is basically a public URL that, whenever an HTTP request is coming in, is sending an event over to either the cone or to one of the sub-agents. And now, yeah. So that, okay. So, we do have the. So the. Damn it. Oh, interesting. Okay. So I broke something. The webhooks are actually working through WebRTC. I'm using a WebRTC gateway. Sometimes it's going to sleep and it's forgetting about it. Doesn't matter. Okay, here we go. So the QR code has been replaced. I think the QR code might not work, but that doesn't. Oh, here we go. Right. So you might be able to try this. There's a chance that they are not going to come through. Oh, it's localhost? Yeah. I'm not, you know what, I'm going to skip this and I'm not going to reload this. But we actually have, so we have a host on slicky.ai, which allows us to have non-local, right? Sending you to localhost. Is basically giving you public webhooks, which is really useful if you're doing things like browser automation. Right, let's say you want to have a notification whenever a new Slack message is coming in. The way you would build that is you would intercept new Slack messages in the Slack application and say, in JavaScript, say, every time that happens, just send a post to that particular webhook, which is then going to the agent. And you've already seen dips. Dips is the same idea, just much faster, much shorter. It's rendering that HTML right in the chat. Again, it's an iframe, so it's properly isolated, but it gives you this real-time interactivity right here and there. And now, why are we holding ice cream cones in our hand at all? And the answer is, of course, because they contain ice cream scoops. And the same thing is true here. So in Slick, we have the ability to have sub-agents. Sub-agents are called scoops. And I can show you. Okay. Okay. So we had a couple of, I don't know what it did. So we have 5 scoops here. We have an IKEA presentation. We have a poet that shipped a haiku, a mathematician that shipped a Dunbar calculation, and the comedian that shipped a joke. Okay. 80 people is approximately Dunbar's number divided by 2. Well, okay. Nice. Okay. So here's another scoop. This is the conference agenda scoop that I just said get going. And it's actually starting to work on this in the background. So I can continue with my presentation, and let's see how optimistic or pessimistic Slick is with regards to the scoop capabilities. So let's talk a bit about architecture. How does this work? And there are essentially 4 pieces that I want to talk about. The first one is this mushy mass that we have here, which is the LLM, right? And Slick supports essentially any LLM that you can think of. We have support for your Codex subscription, for your Copilot subscription, for your XAI Grok subscription. You can bring your Anthropic API key. You can bring your Bedrock API key, OpenRouter, and a bunch of others. And the better the model you pick, the more fun you're going to have with Slick. One of the things that I built in there to make sure that you're not having a bad time is I'm preventing all mini and nano models from running the cone. The cone can still delegate these models for a sub-agent, but you never want this to be your main agent, because your main agent is powerful, and you don't want somebody stupid to be powerful. The second piece is the agentic loop. Right? And the agentic loop is powered by PyAgent, which is exactly the same agent written originally by Mario Zechner, which is powering OpenClaw, which is powering NanoClaw. There's going to be a talk about Pi in detail this afternoon. So I can fully recommend it. It's a fantastic system. And I've been using Pi as an agentic framework for months before I even started using it or looking into it as a coding agent. The next piece of this is the terminal, and you've seen these little commands that have been running here. Some of these are sprinkle commands, but if we go back just a bit, we see, for instance, here this is where we actually call a bash command, and I can open the terminal, and I'm not going to say test again, and we can see everything that's running here. Here we go. We have a list of skills. Here you go. We actually have a GitHub skill, and you can run Git inside. You can run Git inside the browser as well. This is powered by isomorphic Git, which is a tiny Git implementation in JavaScript. Really cool and elegant. And the last piece of the architecture I quickly want to show is you see this cogwheel at the bottom. It's really important because this is a web worker. When I first started building this, basically everything was running nicely in the main thread, which was fantastic because it was super simple architecture. And then I started doing things like let's open the code directory where Slick's code itself is located. And I'm using work trees for essentially every single feature. And most of the time I don't delete them after I'm done, and I'm keeping them in the same directory. So when I then said, hey Slick, look in your own source code and find this particular thing, Slick said, hey, I'm just going to run find. What I didn't know was that find was running over a 50 gigabyte huge directory, right? Dozens of work trees, many copies of node modules, and that wasn't just slow. It completely froze the main, completely froze the rendering. I thought, oh my God, what is happening? Figured it out quite easily. But one of the cool things about this is that with this we actually get a process management. So I can run PS. Is it? Here we go. I can run PSA, and it's actually giving me all of the prompts and all of the commands that have been run since should I say the system booted? No, actually, since page on load, right? I think that's the correct term. So it's giving us the ability to interrupt processes whenever they're going. Here's the presentation. So back to the presentation. The next part of this is that the protocols that are powering Slick are really interesting. So first of all, and I should mention it because it's so obvious, is HTTP, right? So we're accessing it through HTTP, and HTTP is what the agent is using to interact with the rest of the world. It has the ability to run curl. It has the ability to see the world through curl, right? Secondly, it is the Chrome debug protocol. So through the Chrome debug protocol, it is then able to do things like opening new tabs, controlling tabs, changing the font in a tab, and so on, right? So the Chrome debug protocol, again, is extremely powerful protocol, and the way how Slick works with it is Slick has a Playwright CLI installed. It has something that looks like Playwright CLI to Slick. It's actually just a very, very tiny wrapper around the CDP protocol, like the real Playwright CLI. So I had the opportunity to look into Playwright CLI to find out that the mysterious substance that they're cooking with is actually water. We have additionally WebRTC as a key protocol, and WebRTC is what enables the remote licks that you've seen before, the thing that didn't work because it didn't reload properly. And actually, we might, you know what, we might run. Okay. So we can try that later, but WebRTC allows us to take multiple Slick instances and connect them together. This is especially powerful because we have a tool called Slick Start, and Slick Start allows you to not just to start Chrome with Slick enabled, but it's also able to find all of the Electron apps that you are running, and it's then able to launch these Electron apps in debug mode and inject the loading code, the bootstrap code for Slick into this Electron app. Really powerful, especially if you have things that you want to access. And funny thing is, breaking into Slack was super easy. Really child's play. And the hardest to break into was Claude, and I was completely surprised by this because I thought, hey, this is a vibe-coded application. How can they have these security guards, and they have Electron fuses, which are essentially triggers that kill the binary whenever you notice somebody trying to access the debug port. Really cool engineering. Turns out the person who wrote Electron is working for Anthropic, and he's working on the Cloud desktop application. But I can still break into it because we can patch the binary, remove the fuses, and create right. So you can just do things. And I'm getting time checked here. So where were we? We were talking about tools. There's a full toolbox available here, right? We have Bash and everything you would expect from core utils. We have SQLite. We have a Python interpreter there. We have ImageMagick in there. We have tools for dealing with PDF. Last week I've added support for Biome and the TypeScript compiler, because Slick was opening PRs against Slick, of course, but all of these PRs were failing in the linting step, because we've heard that in the last session, right? It's writing sloppy code. So I'm giving Slick a linter that it can run inside the sandbox. And we also have support for MCP. How does MCP support work? Well, in the end, there's an MCP, don't know what's happening here. There's an MCP command line, which allows you to add an MCP URL, and I'm only supporting, right, so there are multiple transports for MCP. Still, the most common is standard in, standard out, which I don't support, but I support the HTTP-based transport. So if you have an MCP server somewhere, you can use it. Max is going to talk about WebMCP later on. WebMCP is also something that can be supported in Slick. Actually, getting WebMCP support into Slick is just tell Slick, hey, search for WebMCP support. It's going to find a fitting skill. It's going to say, oh yeah, WebMCP is really easy. It's just another property on the document, and I can interact with that. And we have, I mentioned, you know what, I'm running my slides out of order here, but you've already heard about remote controlling Slack, remote controlling Teams, remote controlling, I don't know what email client that is running in Electron, but you can probably, actually, Teams is one of these that, yeah, the icon is wrong. But so the last last part that I quickly want to talk about is we have an OAuth token command. And I think the best way to talk about this is to here. So okay, perfect. Look at this. So we have OAuth token as a little command line, and OAuth token allows you to go through the OAuth flow and keep the token stored, and we're actually hiding the tokens from the LLM so that they never actually leak into the context. Which leaves me with one last slide, which is let's get Slick to take a photo of me. And everyone knows how to take a photo on the command line is you run ffmpeg. And then to open this photo, to look at it, and finally to deliver a roast of whatever Slick is seeing here on
3 shades of black, a headset mic, fearless beard, and 2 scoop-shaped spotlights floating behind your head. Lars, the cone really does follow you everywhere, even on stage.
So here we go. My time is over. Thank you very much. If you want to learn more, go to slicky.com, SLICCY.com, or just run npx slicky, and you're ready to go. Thank you.